Hello students. So in our today's video we are going to classify heat exchangers. We already classify heat exchanger in our previous semester in heat transfer subject. But for design of heat exchanger subject we are going to classify heat exchanger in a little bit different manner. So let's start classification of heat exchanger. First, based on recuperators and regenerators, then we will classify according to the transfer process in which direct contact heat exchanger and indirect contact heat exchanger. Then according to geometry of construction, in which tube type heat exchanger, plate type heat exchanger and extended surfaces type heat exchanger. Then according to the transfer mechanism, in which single phase or two phase. And at last according to the flow arrangement, parallel flow, counter flow and the cross flow. So first is the recuperators and regenerators. We know that which are the recuperators, heat exchangers. So in the heat exchanger in which there is no direct contact between the hot fluid and cold fluid are generally known as the recuperator. As you can see in this figure, the hot fluid and cold fluid are separated by pipe, or we can say that by wall. So whatever heat transfer takes place is through this wall. First the heat will flow from the fluid to the inner surface of the wall, then from the surface of the wall the heat will flow to the another fluid. Second is regenerators. In regenerators there is an arrangement from which both the fluid pass one by one. The flow passage, which is also known as the matrix. So the hot fluid stores the thermal energy in the matrix during the cold fluid flow through the same passage. At the later time, the stored energy is extracted from the matrix. So there is one pipe from which first the hot fluid is going to be flow. In that pipe there are some particles which absorb heat from that hot fluid. Now after flow of the hot fluid, the cold fluid will flow from the same pipe. So whatever heat is absorbed by the particle inside the pipe, now that heat is going to be absorbed by the cold fluid. And this cycle is going to be repeat again and again until the required output is not achieved. Next, classification based on the transfer process, direct contact heat exchanger and indirect contact heat exchanger. From the name we can say that in the direct contact heat exchanger, the hot fluid and cold fluid are directly going to contact each other. As you can see from this figure, the steam is going to be entered from this side and the cold water is going to be entered and in this from this side, and steam and cold water both are in with each other, contact with each other in this container. So after receiving heat from the steam, the temperature of cold water is going to be rise. So at the outlet it would be hot water, and the steam is going to be condensed by this cold water. So whatever the gas is whatever gas is generated is going to be coming out from this passage. So heat transfer takes place in this container. The hot fluid and cold fluid both are in contact with each other. So this is a direct contact type heat exchanger. But there is one condition for this kind of heat exchanger. The both fluid are immiscible, means they are not dangerous. They are not going to be mixed with each other, and they are not going to be dangerous to mix with each other. In that case, you have to use indirect contact heat exchanger, in which the fluid, hot fluid and cold fluid, are separated by means of wall, the wall of pipe. Here you can see the hot fluid is flowing from one pipe and the cold fluid is flowing from the another pipe. So both the fluid are separated by one wall, and the heat transfer takes place through that wall. Next, classification according to the geometry, in which there are three sub classification. First is according to tubes, second is plate, and third one is extended surfaces. In tube, which is known as the tubular heat exchanger, we can classify further it by double pipe heat exchanger, Shell tube heat exchanger and spiral tube heat exchanger. The first one is double pipe heat exchanger. We all know that double pipe heat exchanger is or we can say the tube in tube heat exchanger, in which concentric pipes, as you can see in this video, there are concentric tubes. So from inner tube there is a flow of one fluid, and from outer tube there is flow of another fluid, and the heat transfer takes place between this wall. As you can see in this video, there is a flow of one fluid from the pipe and there is a flow of one fluid surrounding pipe, which is known as the shell. So this is how the heat transfer takes place in the double pipe heat exchanger. This configuration is very suitable where one or both fluids are at high pressure. So it is going to be easy to flow. The only disadvantage is that double pipe heat exchanger are bulky and expensive per unit transfer surface. Okay. The next one is the shell and tube heat exchanger. We all know the configuration of shell and tube heat exchanger. This is a shell and there are a number of tubes inside the cell. As you can see, there is a flow of one fluid. Let's take cold fluid from this pipe, and there is a flow of another fluid, cold fluid, from this. So the cold fluid will flow at the outer surface of the pipe from which hot fluid is flowing. Clear? So this is a shell and tube heat exchanger where a number of tubes and there is one shell. Now, last is according to extended surfaces, which is also extended surface, which is also known as the fin, which is used to increase the surface area, which is used to increase the convective heat transfer rate. So in that extended surface heat exchanger, which is further classified as a plate fin heat exchanger, or we can say that our second one is a tubular fin heat exchanger. So extended surface heat exchangers are devices with fins, or we can say that extra surfaces on the primary heat transfer surface or tubular or plate with the object of increasing heat transfer area, as we have just discussed. So this is the rough figure of a plate fin heat exchanger. Generally, plate fin heat exchanger are used where there is heat transfer between gas and gas. So at that time, there is a very low convective heat transfer coefficient. So to increase the heat transfer rate, to increase the value of H, we are adding some extra surfaces to increase the surface area. So plate fin heat exchanger is generally used whenever there is a heat transfer between gas and gas. Okay. Second one is a tubular fin heat exchanger. Here you can see that there is a tubular fin heat exchanger. So here you can see there is some extra plate, or we can say that the extra surfaces which is provided to this tube from which liquid is flowing. So this increased surface area, increased value of H, increased surface area, increased value of H, which is overall increased in a heat transfer rate by the convection. In this video you can understand there is a flow of a fluid from this pipe. So we provide some extra surfaces, or we can say that extra pipe, to increase the surface area, and overall increasing in this surface area will result in increasing convection rate, so that the heat transfer rate. So this is the one form of heat exchanger by extended surfaces, which is known as the tubular fin heat exchanger. So now the last one, according to heat transfer mechanism, single phase and two phase. So in single phase and two phase, the hot fluid or cold fluid, in a single phase, the hot fluid and cold fluid remains in the same phase of liquid. As you can see that here you can see the whatever heat transfer takes place between the hot fluid and cold fluid, neither of them are going to change their phase. They are going to be stay in liquid form. In a two phase, here you can see that in a now the last one is according to the heat transfer mechanism, single phase or two phase. So as we have already studied about condensation in condenser and evaporation, what happened in condenser, we know that the temperature of hot fluid will remain same. Whatever heat is going to be absorbed by the cold fluid is the latent heat which released by the hot fluid. So here the temperature TH1 and TH2 will remain same. The heat which is going to be supplied by the hot fluid is the latent heat which is received by the cold fluid. So in an example of a refrigerator, we know that in a condenser, the refrigerant enters in a after coming out from the compressor at high pressure and at a high temperature. So it is in a gaseous form. So at the entry time, the refrigerant is at a high temperature and in gaseous form. After coming out from the condenser, whatever heat is going to be released in environment, or we can say that the cold fluid, the refrigerant is going to be changed the phase by releasing latent heat, and it is going to be converted into the liquid. So there is a phase change. as well as in evaporation. After coming out from the condenser, it is going into expansion valve, where the pressure drop takes place and further temperature drops takes place. So that low temperature cold refrigerant is going to be in evaporator, where in a liquid form, where it absorbs the heat from the evaporator space, and that heat is going to be latent heat, and because of that latent heat, it is going to be convert from liquid to the gaseous form. So here this is a phase. Whenever there is a phase change of the hot fluid or cold fluid, so this is a single phase. In a two phase, both the hot fluid and cold fluid is going to be change their phase. Whenever there is a condensation at one side and boiling at the another side, at that time two phase heat exchanger is going to take place. Otherwise, mostly there is a single phase heat transfer from hot fluid and cold fluid. There is a one fluid which is going to release or absorb the latent heat to change the phase. At the last, according to the flow arrangement, parallel flow, counter flow, and the cross flow. We know that in a parallel flow, the flow direction of both the fluid, hot fluid and cold fluid, is same, as you can see in this figure. In cross flow, the flow direction of hot fluid and cold fluid are different, opposite to each other. And in a cross flow, there is a flow of hot, as you can see in figure, hot fluid flowing in this pipe and cold fluid is flowing randomly on the surface of the fluid. So this is the temperature versus length diagram. The temperature of hot fluid is continuously decreasing and temperature of the cold fluid is continuously increasing in parallel flow configuration. This is a T hot temperature. As well as in a counter flow, there is inlet, hot water inlet is here, so TH1. Now temperature of hot fluid is decreasing. Cold water entering point is here, so this is TC1 and this is TC2. The temperature of cold fluid is increasing. So this is the classification of heat exchanger for the design of heat exchanger subject. You can also classify heat exchanger which we have studied in according to heat transfer subject. Both are correct. This classification is little bit in a detailed view. That's it for today. Thank you so much.